Okay, so right now we're going to talk about the unit circle. Basically, it's foundational to understanding trigonometry, which is a big part of algebra. Which is a big part of pre-calculus, along with algebra 2 and a few other concepts. So what you need to know about the unit circle is it's essentially the graph of a circle, right? That has a radius of 1. That's that's why they call it unit. Unit kind of stands for 1. And here's what you need to know about it. Um, the easy, a lot of teachers will try to tell you to memorize it. I don't really recommend it um, because there's an easier way to understand it. So here's what's going on in a unit circle. You basically have 5 points of interest that repeat all around the circle. So you have 0 degrees, right? You got 0 here. You have 30 degrees. You have 45 degrees. You have 60 degrees. And you have 90 degrees. Once you know the sine and cosine values for all of these, they repeat, right? They reflect all over the circle, either right side to left side or top to bottom, okay? So just know these 5 and you're good. You don't have anything to worry about or memorize, and I actually have a convenient trick for you. So let me just write down what you need to know. You need to know step 1. Let's see. Step 1, you need to know 0, 30, 45, 60, and 90 degrees, all their multiples. You need to know for each of these angles the sine and cosine values for each of those 5 angles. And the last thing you need to know is how to convert from degrees and radian to radians and back. Okay. Once you can do that, you're pretty comfortable with the unit circle. So what do I mean by sine and cosine values? In a unit circle, your y-axis is actually representing the sine of an angle, which is the height, basically. Your x-axis is actually representing the cosine of an angle, which you can consider as the width. Okay, so if we were to turn each of these dots into a triangle, it would look like this. You just drop a straight line down, go like that, boom. That blue line is the height or sine of this 30 angle. Sine of 30 is the height of that blue line. Boom. Sine of 45 is the height of that blue line. Boom. Sine of 90 is the height of that blue line. Obviously, the sine of 0 is 0 because it's flat, right? And the sine of 90 is 1 because, as we just said, the radius of a unit circle, right, this is 1. All these points are 1. So this would be -1 on your unit circle. And to the left, this would be -1 to the bottom. Okay, similarly, let's pick another color, green. The width of a unit circle, obviously the width at 90 is 0 because you don't go anywhere. But the width at 60 is cosine of 60, right? Cosine of 60. So you can think of it as the distance from here to here or the distance from here to here. Same thing. Cosine of 45 is this distance, which you could also think of as this distance. I like to think of it as the bottom of the triangles, personally. Cosine of 30 is this distance. Let me make that better. This distance. This width, which also could be the width of the bottom of that triangle. Okay? So now, obviously, cosine of 0 is 1, right? Just like the sine of 90 is 1, cosine of 0 is 1. So now you have the breakdown of how to look at a unit circle. So what are these values? Okay, I have a pattern for you. It goes like this. Let me just type it out. For sine, it looks like this, and for cosine, it looks like that. So let me just make, we got 0, 30, 40, 45. These are the only angles you're expected to know, by the way. In a unit circle, 60, 90. Okay, so basically I got 3 columns. Okay, so sine of 0, the pattern is, it goes like this, watch. It goes, I'll use blue for sine, just to keep it consistent. Sine of 0 is, you're going to do 0, 1, 2, 3, 4. Then you're going to take all these numbers and divide them by radical 2. So 0 divided by radical 2. Actually, let me move cosine over so it give you space for what's coming. So then 1 divided by radical 2. 2 divided by radical 2. 3 divided by radical 2. 4 divided by radical 2. Let me see if I'm doing this right. Hold on a second. Yeah, I think I'm good. Okay, so this will come out to, hold on a second. 0. Hold on a second. Sorry, it's not over radical 2. It's divided by 2, period. I knew I was forgetting something. Like, why isn't this making sense in my brain? Okay, so all of these divided by regular 2, not radical 2. Okay, so let's redraw that. So 0 over 2, over 2, over 2, over 2, over 2. And the radical actually goes on the number on the top. So radical 0 over 2 equals 0. Radical 1 over 2, radical 2 over 2, radical 3 over 2, radical 4 over 2. So you simplify this. Well, radical 1, square root of 1 is just 1, so this is 1/2. Radical 2 over 2 can't be simplified, so it stays like it is. Radical 3 can't be simplified, so it stays like it is. Radical 4 over 2, well, the square root of 4 is 2, so this is just 2 over 2, which is just 1. So 2 over 2 equals 1. So now we know the height at each of these points. At 0 degrees, the sine or height of your triangle is 0. At 30 degrees, the height of your triangle in a unit circle with a radius of 1 is 1/2. At 45 degrees, the height of this triangle in here is radical 2 over 2. At 60 degrees, the height of this triangle here is radical 3 over 2. And at 90 degrees, the height is 1. Okay, for cosine, I'm use green. You could actually do kind of the same thing, but in reverse. So at 0 degrees, we're going to do 4, 3, 2, 1, 0. Divide them all by 2. Divided by 2. So instead of memorizing a whole bunch of random stuff, you can just kind of take advantage of this pattern that I found. Over 2, over 2. Then you just radical everything in the front. So it's radical 4 over 2, radical 3 over 2, radical 2 over 2, radical 1 over 2, radical 0 over 2. Square root of 0 is 0. Anything 0 divided by anything is 0. Square root of 1/2 is just 1, so that's 1 over 2. Radical 2 over 2 can't be simplified, so it stays like it is. Radical 3 over 2 can't be simplified, so it stays like it is. Radical 4 over 2 is just 2 over 2, which is 1. Okay? So what that means on the unit circle is the cosine at 90 degrees, which is down here, is 0, right? There's no width. I don't have to travel any distance to get to this spot from the y-axis. It's just 0. The width at 60, right, from here to 60-degree point, or the bottom of this triangle here, is 1/2. The width of your triangle at 45 degrees, right, is radical 2 over 2. The width of your triangle at 30 degrees is radical 3 over 2. Oops. And the width at 0 degrees says come from the origin, the center, all the way out to 0 degrees on the circumference, and that width is 1. So I hope that helped you guys get a sense, because it's the same thing all over the circle. So for example, before I cut this off, this point here will also have the same width as 30, but the height will be negative, right? So 30 degrees width is radical 3 over 2. Its height is 1/2. So this would be, its width would be radical 3 over 2, but negative 1/2, right? So the width is radical 3 over 2. The height is negative 1/2, because remember, you're just on a graph. You're below the x-axis here, right? This is the cosine of x. This is the sine of x. Same thing here. This point down here, if you just drop a straight line, it'll have the same width as cosine 45, right, which is radical 2 over 2, but the height is negative, so it'll be negative radical 2 over 2. Same thing here. If you drop a straight line, same width that's cosine 60, which is 1/2, but the height is negative, so you got negative radical 3 over 2. And of course, that negative down here, the height is -1 and the width is still 0. So you can reflect this all over. Same thing over here. Come to this side, still has the same height of 30, which is 1/2, but the width is negative now, so negative radical 3 over 2. Over here, same height as 45, but the width is negative, so it's radical 2 over 2.
It's 12:45.
Sorry about that. It's radical 2 over 2 for the height, but the width is negative radical 2 over 2. And over here, the height is still the same for 60, so sine of 60, radical 3 over 2, but the width is now negative, so -1/2 is your width from the y-axis to this point on the unit circle. And of course, over here, everything is going to be negative, right? It's going to have the negative height of what's up here, the negative height of what's up here, the negative height of what's up here, but the width will be the same, right? They're both, all these widths are negative because they're on the left side, right? So you're on the negative side of your graph. So you could clearly just start drawing lines over, negative height, negative height, negative height. So if you keep this graph in mind and you understand what's happening, it basically, all you need to know is this first quadrant, and then start reflecting things to match up with where you actually are located. All right, so 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210 degrees, 270 degrees, 240 degrees, 270 degrees, 300 degrees, 330 degrees, and 360 degrees. Hope that helps. If you need any extra help or explanation, just let me know in the comments, and I'll respond and maybe remake this video or add something extra to it. Thanks, guys.